Okay, we're going to start in the notes packet here, but then we're going to go rogue a little bit for the same reason that this packet was made before spring break, before we kind of cut things down a little bit and we're really targeted to what we really need to know. So we're going to fill out the idea of probability here, and then I'm going to grab a separate sheet of paper and we're going to do some problems on a blank sheet of paper. So you can grab like a notebook piece of paper or a blank sheet of paper before we start, and then we'll fill out the little bit of notes part here. So if you need a pause to go grab a paper, you certainly can. And probability itself is something that we're used to. So, for example, probability is the likelihood of an event. Okay, so for example, what's the probability that you will have a quiz this Friday? It is certain, right? Because you're going to have a quiz every Friday over the previous week's material, so the probability is 1. So what you're most familiar with, though, is if there are 5 girls and 6 boys, and I put them all in a sack and mix them up, what's the probability that I pull out a girl? So that would be 5 over 11. Right? So what you do is you put your girls over the total. Okay, so that's probably something that you're more used to, probability not being in geometry, but in other situations. So another way to write this is if you actually divide these, then you get a decimal like you see along this continuum. So 5 divided by 11 is 0.45, which would be right about here. So it could also be 0.45 as a decimal, or third option, it could be 45%. Okay. Because again we're typing this into Desmos, and because of the fact that it's just going to be easier, we're going to leave everything in the decimal form. Okay, it's easier to type that into Desmos after you've shown your work, and it's going to be easier for you so you don't have to type in a crazy fraction, because the fractions are going to get crazy when we do our geometric probability. Okay, so geometric probability is the likelihood of a particular area. Okay, so it's the likelihood of an area within the shape. Okay, and I'll show you why this, again, we kind of knocked it down to the essential parts, so kind of deemed that that's not essential, so we're skipping over that. Kind of show you why we're not doing this. Again, it says find the probability of the shaded region. Okay, and again, this isn't very shaded. Okay, and also these two particular problems are pretty complex. Okay, so we're going to simplify it down a little bit. You will see a complicated problem today and some more complicated problems on Wednesday, but we're going to go to just a little bit more basic problems to start today. So I've got my separate sheet of paper here, and we're going to draw on that separate sheet of paper a square with a circle in the middle. Okay, now again, my drawing is not fantastic and yours doesn't have to be either, but this is called, when they come together at a point, that's called that they're tangent to each other. I kind of missed over here, so this circle is tangent to the square because it fits exactly in the square. It's not like sine, cosine, tangent, but that's just a little piece of vocabulary to throw in there because we actually didn't cover tangent circles in chapter 10. So we threw out chapter 10, and so we didn't get that information, what a tangent could be besides sine, cosine, and tangent. Okay, so hopefully I gave you enough time there to draw a square with a circle inside of it, and the side length of the square is 14. So when we do geometric probability, it's going to kind of be the same as when we were doing the probability of girls. So what you do is you put the probability of what you want on the top. I am always going to want the shaded, so the shaded part, okay? That part is going to go on the top. Okay, because that's what I want. And then you're going to divide that by the total. And in this case, it will be the total area, which is just the area of the largest, area of the largest shape or figure. Okay, so in our case right now, that's going to be the area of the square. Okay, so first thing, the easiest part first is that bottom part, the total area, the area of the square. That part's going to be easy. It's a square, so it's going to be 14 times 14, which is 196. Okay, now let's talk about the more difficult part. Now we've been dealing with stuff like this especially in 11.2, where you saw some, 11.2, where you saw some in the notes and in the homework, but nothing like that actually showed up on the quiz, where you had to take the big minus the little to get the shaded region, and that's exactly what we're going to do here. So the big minus the little means I need to take the square and actually subtract out the circle. So I'm going to go ahead and draw in here what the radius would be. So the square is our 196. We already know that. So I'm going to do the square, which is 196. And then I will subtract from that 196 the circle. So my circle is 7 squared pi. Okay, so imagine typing that fraction into the Go formative. No, that's not going to be fun at all. So what we're going to do is we're going to deal everything in decimal. You don't have to leave anything in terms of pi or anything special. It's all going to be decimals. Okay, so we'll go 196 minus, you can type in 7 squared pi, or you can just type 49 pi, which gives me a decimal of 42.06. So again, typing that into Go formative, I mean, you're still going to have to write that when you're doing your work. But now, if I put this into a decimal, that's a lot easier to type into the answer blank. So that's why we're going to do decimal. So this actually would be the fraction, but the fractions don't make as much sense as they do when you're finding the probability of picking a girl out of the total. Okay, so we're going to go ahead and do the decimal. So I'm going to take that answer and divide it by 196. And my decimal will go to the hundredth, so 2 decimal places would be 0.21 or 21%, but 0.21. So let me tell you something also. Going back into the notes really quick, you see that certain is 1 and impossible is 0. So every answer that you get on these problems is going to be between 0 and 1. If you get something bigger than 1, we've done it wrong. Okay, everything should be between 0 and 1. So if you're getting answers like 0.21 and you're like, I don't know if I'm supposed to be getting a decimal, everything is a decimal between 0 and 1. Okay. Okay, so I flipped the script on this one, and I've made a circle, and then I've put a square inside of the circle. Okay, so when you put the square inside of the circle, you've got to tilt it. Okay, got to kind of turn it sideways. And I kind of didn't even these out here. This should be a little bit more over there. But again, your picture doesn't have to be perfect. My picture doesn't have to be perfect. Okay, we're doing the best that we can with this online learning business. Okay, so again, the bottom is always the easiest. It's the area of the biggest shape. My biggest shape here is the circle, right? So the area of the circle is going to go on the bottom. And then typically, you're going to see that that area also repeats itself on the top when you go the biggest minus the inner shape. Okay, so again, we're going to do the shaded area over the total. And the total is the circle. Okay, now because you guys have a packet, right? That packet does have all of the formulas across the bottom. Okay, it's got a triangle, rectangle. This one we, again, cut out because of time's sake, but this is a trapezoid, circle, and your regular polygon. Now, we didn't do this exact formula, so we'll kind of talk about that in just a second, but this guy right here, pi r squared, if you need to have that, that's always in your packet, okay? We are moving into this next, so none of this is stuff that you know yet. But these down here, and then you've got your arc length and your sector area right there. So any of the formulas that you need are always on the sheet that you have for your notes packet. All right, so my total, hopefully I gave you enough time to draw that circle and square. So my total is the circle, and my radius for the circle would be 8. So on the bottom is 8 squared pi. So that's 64 pi. You can leave it like that, or you can turn it into a decimal now. It doesn't matter. I'd just leave it because you got to type it all into a calculator later anyway, so we'll just leave it for now. Okay, so then on the top, when we do the top, what we need to do is to find the shaded area is you need to take the big shape and you need to minus the small shape. Well, I know what the big shape is. This is going to be that 8 squared pi. So this is what I was trying to hint at, that whatever the total is, that total is going to repeat itself up here, and then you're going to subtract. Okay, now there's one case where that's not going to happen, and you're going to see that in a little bit, but that can happen. It's going to happen most of the time. Okay. I'm going to subtract out my square. Okay, well, this square, I threw this one in there. We've got to find the side length of the square so that I can do that times itself and get the area. Well, every square is 8, and do you remember what the other side would be with your special right triangles? It's x, and x radical 2. But even if you didn't remember that, you could do Pythagorean theorem right here. So it'd be 8 squared plus 8 squared equals c squared. But in a square, it's 8, 8, and 8 radical 2 on the side. Okay? So for that part right there, we're going to take 8 radical 2 times 8 radical 2. That's going to be your square. Okay, now I'm going to caution you that typing that into your calculator is going to be complicated. Typing it into Desmos, not complicated, but typing it into a calculator is very complicated. So I'm going to kind of cheat a little bit. Again, I wouldn't cheat if we were actually at school doing this together, because then I would know for sure that you were typing it correctly. So if you're typing that into your Desmos, And I know a lot of you are using that Desmos, so I'm going to just show this here. Let's try a little bit more. There we go. Okay, so when you're typing in, you go 8 radical 2, and then you tap outside of that to get out of the radical, and then you type 8 radical 2 again, and you get an answer of 128. Okay, I didn't even have to put a times in there, but you certainly can put a times. Okay, so it's 128. Now, if you are not using that, my cheat again, so here's just like a regular calculator. And let's see if I can get the brightness to turn down so you can see it a little bit better. There we go. Okay, so on a regular calculator, 8 radical 2. Okay, so you actually have to also get out of this. So you have to get out of that and then go times 8 radical 2. Okay, so on my brand new TI-84 Plus Color Edition, it's actually not as difficult. However, most of you, whatever calculator you have at home, will pop up a parenthesis, and then you have to worry about getting another parenthesis in there. Okay, so what I would do is I would do 8 radical 2, and then just hit enter. Okay, and then you need to take that number times itself. So you've got two options. You can just take that decimal. So 11.3137 times 11.3137. And you get something that's super close to 128. Okay. Or once you get up here, you can hit squared. And if you hit squared, that'll give you that 128 as well. So when you're at home and you can't really get help with a calculator or something like that, go ahead and just change things into decimal and then work with the decimals. Okay, so we figured out that this number is 128. So here's what I've got. I've got 8 squared pi minus 128 over 8 squared pi. Okay, so now we're going to turn these into decimals like we did on the last one, and then divide. So 8 squared pi minus 128 is 73.06. And then on the bottom, 8 squared pi is 201.06. And then you divide those two. Okay, divide them and actually get a single decimal. It's just a lot easier to type into your Go Formative when you do your practice quiz and your actual quiz next week. So 73.06 divided by 201.06 is 0.36. Or 36%. So there's a 36% chance that if you were to pick a point inside of this area, it would be in the shaded region. Okay? And it should be small. These areas, these shaded areas, are much smaller than the areas on the inside of the white space. So it should be a small decimal. It's less than half. Okay, let's do two more. So this one's a little bit more complicated, and the last one's probably the most complicated. So we've got a circle, and then we've got a pentagon inside that circle. And I gave the radius of the shape, so we are going to need to use sine and cosine. So as we proceed forward, my assumption is that you know how to find the area of this pentagon. So although you're not being tested, per se, on pentagons again by themselves, you do need to be able to find the area of a pentagon, because what we're doing next is we are going into three-dimensional shapes, okay, like a cylinder or a pyramid, okay, and it could be a pentagonal pyramid. So if you don't know how to find the area of these shapes, those are going to keep coming back again and again, okay, so make sure that you know how to find the area of these shapes. And if you don't, just contact me and we'll do a quick one-on-one session and hopefully refresh the memory, because it's going to get harder from here on out. Okay. Okay. So again, we're doing the shaded over the total. So the total is 10 squared pi. Okay, circles are always radius squared pi, 10 squared pi. The shaded, in this case, is going to be the big shape minus the pentagon. Okay, now what I'm going to do is I'm going to slide over to this extra space over here, and we're going to work through the pentagon, and then I'll bring that number back over here. Okay. Okay, now if you were working this on GoFormative and you didn't want to type in all of this craziness or draw that all, if you wanted to just get the decimal for that, so 100 pi, which is just going to be 314, 314.15, okay? You could put 314.15 there and you would be able to type that in. So if you don't want to write that into your GoFormative and you want to write that on a piece of paper and then put this into the workspace, you can do that instead of using your finger or typing that out, because that's kind of not a nice thing to have to type. Okay, so over here on our pentagon, okay, so we have 5 of these shapes, right? This side length here is 10. Let's bring down the apothem. Draw in our 90 degrees. Let's put X on the half of the base, because I need to know what that is. And let's find this angle measure. So I'm going to do 360 divided by 5, which is 72. But then I'm going to cut that in half, because 72 is these two angles together. So when you cut that in half, you get 36. Okay, because I was given a radius, you need to use sine and cosine to solve this problem. So we'll go sine of 36. And then cosine. Now I know some of you use tangent as well, which is perfectly acceptable. But you have to do a sine or cosine first. I like to just do sine and cosine, set them up. They set up almost exactly the same. And then when you're typing them into the calculator, they work almost exactly the same. Okay, so I'll go 10 times the sine of 36. Just 5.88. And then this is 8.09. Okay, so then to find the area of this pentagon, you take 5.88 times 8.09 times 5 sides. So I'll write that down. You can type it into your calculator if you want, but I'm going to write that down. 5.88 times 8.09 times 5. Which is 237.846. That's what my calculator says, so I just wrote down all the numbers, okay? So that's the number that's going to go here. Okay, now I type the top into my calculator, get a decimal, type the bottom into my calculator, get a decimal, and then divide the two. Now, if you wanted to, you could type this all into your calculator in one step, as long as you put parentheses around the top. So if you're trying to type everything into your calculator all at once, you actually can do that, but you need to put parentheses around whatever you have on the top. Okay, so you can try that out now if you want. I'm going to go ahead and put the decimal, and our decimals will be a little bit off, but that's okay. Just go ahead and type the whole top into your calculator and then hit divide by and then type the bottom. We'll see if we get the same thing. So I've got 0.24. So when you typed in the entire top in parentheses divided by the bottom, you should get about 0.24. If you're not getting that, or if you're not comfortable typing that all into the calculator, you can do what I did. I did the top, got a decimal, did the bottom, got a decimal, and then divided. Okay. Okay, last one. So what we have here, these are called concentric circles. Concentric just means that they all have the same center. So basically you're drawing 3 circles, and then you're filling in the space in between the first and the second. Okay, so they all have the same center. And this one is quite a bit more complicated again. So you're drawing 3 circles, kind of like a dartboard would be concentric circles. I'm just not drawing the little wedges on the dartboard. This is more like an archery target, maybe. Yep. Okay, and then when I drew the radius, what I did is I put tick marks on all 3 spaces, just showing you that those spaces are the same. Okay, so the radius of the largest circle, so this radius is going to be 15. This radius is going to be 10. And then the smallest radius will be 5. Okay, so here we go. We're going to do the shaded part. That's going to be a little bit involved over the total. This is an example. I said most of them, whatever the total is, will repeat itself up at the top. This is an example where that is not the case. Okay, so let's do the total first because that's usually the easiest one to do. Okay, so this total radius is 15. So the total is 15 squared pi. That's the total. Now the shaded region. The shaded region actually has nothing to do with this part of the radius. So the largest circle has nothing to do with the shaded part. It's only just this little piece in here. So what we're going to do is we're going to do kind of what we were talking about, like the big minus the little, right? So, but the biggest circle is just right in here. So it's, again, it's a donut, but we're not looking at this largest circle. This largest circle has nothing to do with it. So this circle has a radius of 10 squared pi. But if you left it as 10 squared pi, you would still have this inner part. So we've got to take that part out. So that means minus. And this inner part is 5 squared pi. Okay. So on Wednesday, just as an FYI, we're going to be going over more of these problems. So if it seems a little bit complicated, that's okay. We're going to do some reviewing, again, some more problems like this on Wednesday. Okay, so again, you can put the top part in parentheses and just type the whole thing into your calculator. So that's 235.62 on the top. If you're just typing it in piece by piece, 86, round that up, 86. And then you divide those two. Okay, now if you have the exact, if you typed all of this in, you actually get 1/3 or 0.333, which is, I'm going to leave it as a decimal, so 0.33, but that's 1/3. Okay, so on the homework packet, and this will be posted on Power School Learning as well. So on the homework packet for 11.4, you got to kind of skip a few pages for 11.4. Okay, we're going to do 5, 6, 7, and 10. Okay, these other triangles have a lot of special parts to them, which actually isn't going to show up. Again, essential information. These are kind of a little bit more difficult, so we don't want to make you do extra stuff. Okay, number 6 right here, though, if it's hard for you to tell, the shaded region is that part right there. Shaded region is the little circle. And the shaded region is the parts outside the two circles here. Okay? All right, good luck.